Alright, so today we are talking about scale drawings and models. Our I can statements for the day are going to be I can interpret scale models and I can use scale factors to solve problems. So we've already talked about scale a little bit and how it is a way to show something that is really, really big or really, really small in a manageable way. So we have 3 new vocab words today. Really, there's only one that truly matters, and that is scale. So a scale model is a model of an object that is larger or smaller than the actual size of the given object. So if you were going to draw a map of a country, you couldn't actually make that map the size of the country, so you're going to have to make it smaller than the country. Likewise, if you're going to create a model of an atom, if you drew the model, or if you made the model of an atom the size of an atom, no one would be able to see it. And this is the same with scale drawings. So, like I said, if you're going to make a map, you can't make the map as big as the area actually is, unless, of course, it's like a ant farm, I suppose. But likewise, if I wanted to make a drawing of a elephant, I suppose I could make it as big as an elephant, but I can't draw things that are little, so how am I going to draw something that big, you know? So scale drawings are just a drawing to show a real object with the size reduced or enlarged by a set amount. And that set amount is the scale. So the scale is a ratio of the length of corresponding parts on a model or drawing to the real thing. So essentially, let's say I was drawing an elephant. This is going to be a horrible idea. But anyway, we have drawn the world's You know what? I'll be honest with you. That could have gone worse in my world. So let's just say the leg of this elephant is 1 inch. Let's say the elephant in real life is, I don't know, their leg would be like 48 inches or something like that. I genuinely don't actually know how tall an elephant is. They have a stuffed one up top at the Cabela's, but haven't really gotten close to that. Let's see, elephant height. Haha, this is what we need. So elephants are about 10 feet, and it looks like their legs are less than half of that. So I would guess 48 inches is probably a pretty good guess. But anyway, so that would mean our scale would be 1 to 48. 1 inch to 48 inches. So the real thing is 48 times bigger than my drawing. That's how scale kind of works. So continuing on, let's look at a couple example problems. So big thing with scale, you're going to see a ton of maps. We won't be able to mess around with maps as much this year just because I can't give out rulers for people to use. But so anyway, on a map, the distance between Boston and Chicago on a map is 9 inches. If the scale of the map is 1 inch to 95 miles, what is the actual distance from Chicago to Boston? So what they're saying is essentially on the map, we have 9 inches from Chicago to Boston. Let's see how we can do this here. 1, 2, 3, 4, 5, 6, 7, 8. Close enough. I believe that's 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 9 inches. We're going to pretend that they're all perfectly evenly spaced and that they are actually an inch. So what this scale says is for every inch, we actually have 95 miles in each one of these. So in order to find the actual distance, we could add 95 together 9 times, or we could just say 9 inches, 1 inch equals 95 miles. So 9 times 95 is going to equal my total distance, which I believe would be like 855. If I'm not mistaken, 9 times 95. Yeah, 855. So it'd be 855 miles. So some people set up proportions for these, and personally, I just kind of read the problem and organize it in my head. But if you wanted to make a proportion for this, you could say 1 inch is 95 miles. So 1 inch, 95 miles. There are 9 inches in the drawing. How many miles are there in real life? So we have our unit, so kind of our single piece, our 1 inch, 95 miles. We have our small unit on top, and then we have the real distance on the bottom. And we could cross multiply to get our answer here. It would be 9 times 95 equals 1x, and that would be 855 miles. So if you prefer to set up a proportion, feel free. But me personally, I just like to multiply it out. So the distance between Cheyenne, Wyoming and Tulsa, Oklahoma on a map is 8 inches. So the distance there is 8 inches. The scale on the map is 1 inch equals 90 miles. So if 1 inch equals 90 miles, then 8 times 90 would be the total distance, which would be 720 miles. Lovely, lovely, lovely. So now, the map problems aren't wildly terrible. They do get a little bit more confusing, in my opinion, when we get to our models, just because they like to get weird and do different things with it. So in this one, a miniature replica of a fighter jet is 4 inches long. The actual length of the fighter jet is 12.8 yards. So the replica is 4 inches. The real thing is 12.8 yards. What is the scale of the model? So anytime we're trying to get the scale, what we want to do is we want to divide by the same thing on each side. So I want to say 1 inch equals how many yards. So I'm going to divide by 4 on each side. 4 divided by 4 is 1. So 1 inch equals 12.8 divided by 4, which I believe is 3.2. Equal, we'll make that a clear one, equals 3.2 yards. So 1 inch is 3.2 yards. That's our scale here. Now, that part's not wildly terrible. All we are doing is we're saying, okay, our model, our little itty bitty airplane, yeah, I know what you're thinking. Wow, that is a great airplane. And you're right, but this is actually a model airplane. Now, the big airplane, the real deal, is going to be much, much bigger, which is where the drawing skills really come in handy. You know, those drawing skills that I most definitely have, theoretically. Now we're going to need the pixel eraser here, not the object eraser. There we go. There's our lovely airplane. So our model, 4 inches, our real plane, 12.8 yards. So what we're saying is, okay, what is a unit that we could say that would make sense to make a scale here? So we typically want 1 of something equals the bigger thing. So whether it's 1 inch equals 3.2 yards or 1 foot equals 200 miles, whatever, we want to get it to 1 equals something else. So that's how we found our scale factor. Now, this is where they get a little bit more confusing with it. So we just said 1 inch is 3.2 yards. Now they're saying a miniature replica of a fighter jet is 4 inches long. The actual length of the jet is 12.8 yards long. How many times as long as the actual is the model jet? So how much bigger is the model jet than this replica? So now how we have to do this. So we have our scale factor. We have our 1 on this side. We have our other unit on this side. Now, these are in different units of measurements right now. So we have 1 inch to 3.2 yards. Those are very different units of measurement. So what we need to do to figure out how much bigger the actual plane is we have to get this right side, this 3.2. We have to convert that into inches. So all we're going to do is we're going to say 3.2 times 36 because there's 36 inches in a yard. So we're getting that to the same unit of measurement. So we're saying 1 inch on this replica is going to equal 115.2 inches on the real deal. So in that way, the real deal is 115.2 times bigger. And that would be our answer. So we have to make the labels match to get that how many times as long as the actual thing or how many times bigger, when they start talking like that and making it a little more confusing. All right, so a miniature replica of a fire engine is 9 inches long. The actual length of the fire engine is 13.5 yards. What is the scale of the replica? So once again, I would say 9 inches is 13.5 yards. And personally, I like to divide it to 1. However, I can see right now that that's not going to work because they're monsters. So in this case, I would just try to guess and check. So if I divide both sides by 9, I'm going to get 1 inch is 13.5 divided by 9. It's going to be 1.5 yards. So 1 inch is 1.5 yards. Now, I see that's not an option. However, I do see we have a couple 2-inch options. And if I multiplied this by 2 and multiplied this side by 2, I would end up with 2 inches equals 3 yards. So I would see that A is the answer. Not in love with that question, but you can always take it down to 1, and then you can back off from there, and you can multiply back up to whatever your options are, because it's really easy to manipulate once it's in 1 to whatever format. So 1 to 1.5 yards, or 1 to 9 miles, or 1 to 3.2 centimeters, whatever it is. Once it's in that unit, base unit format, then no matter what we multiply it by, we at least can do one of them in our head. So whatever times 1 is going to be that original number. All right, continuing on, a miniature replica of a fire engine is blah, 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 blah. How many times as long as the model is the actual fire engine? So we said 1 inch to 1.5 yards, and a yard is 36 inches. So 1.5 times 36 would be 54. So 54 inches to 1 inch. So it would be 54 times as big. Lovely. So Gerard is making a scale model of his classroom on an 11 by 17 inch sheet of paper, which is really weird. I don't know anyone who walks around with an 11 by 17 inch sheet of paper. If the classroom is 20 feet by 32 feet, choose an appropriate scale of the drawing to determine the drawing's dimensions. So there's two ways to look at this. One, do I want to make it fit the piece of paper, or do I just want to set a good scale? So me personally, I look at this and I say, okay, if I multiply 11 by 2, I get 22, and if I multiply 17 by 2, I get 34. So if I used a 1 inch to 2 foot, 1 inch to 2 foot scale, then that would pretty much fill up the paper, and it's a nice, easy scale factor. That's how I would look at this, knowing that, yep, that would work. Now, there's another way to look at this, and personally, in my class, I would say, yep, if you said 1 inch to 2 feet, that's perfect. That's a acceptable scale factor. The second way you can look at it is, I have a classroom that is 20 feet, 20 feet by 32 feet, and I have a paper that is 11 by 17. I need to make them match exactly. And if you wanted to do that, you could set up a proportion and see if they're proportional, if it would even work. So you could say 11 over 20 equals 17 over 32. Then we would do a little cross multiplication. So 20 times 17 is 340, and 11 times 32 is, okay. So they're not exactly proportional. So we couldn't make it fit the paper exactly if we wanted to. We could get pretty close. But in light of them not being perfectly proportional, you could make one side perfect. And how you would do that is you would say, okay, 11 inches is 20 feet. So let's divide that by 11. So now we have 1 inch is 20 divided by 11, 1.8 feet. So essentially what I did there, let me just do some quick maintenance cleanup work here. So essentially what I said was, we have an 11-inch piece of paper, we have a 20-foot room. I want to get a scale factor of 1 in this case, making these match up exactly. So to do that, what I did is I divided by 11 on top and bottom, which gave me 1 on top, because 11 divided by 11 is 1. So that would be 1 inch to 20 feet divided by 11, which would be 1.81 repeating. Feet. So I have 1 inch to 1.81 feet. And if I used that scale throughout, then this measurement on the classroom, this 20 feet, would fill this 11 inches on the paper exactly. So you could do that and say your scale factor is 1.81 repeating. But to me, it's just a lot cleaner to say 2 feet. But it's your call. Your life, live it how you choose. So Elena is an architect making a scale model of a house in a 15 by 26 inch display. If the house is 84 feet by 144 feet, what would be the dimensions of the model using a scale of 1 inch is 6 feet? So if I have a scale of 1 inch equals 6 feet, then what I want to do is I want to say, let's look at each of these dimensions individually. So I know the house is 84 by 144 feet. Now, if I divide that by 6, so if I divide each of these by 6, then I'm going to know what the inch dimension for each side is. So 84 divided by 6 is 14. So 14 inches by 144 divided by 6, which should be 20. 24. So the dimensions of my display would end up being 14 inches by 24 inches. And why that works, so if we had super big house that's a perfect rectangle, because these people are weirdos. So we have 84 feet by 144 feet, and now our scale is 6 feet is 1 inch. So essentially what that's saying is for every 6 feet in these dimensions, we're going to have 1 inch on our model. So I'm essentially cutting this up into 6 feet increments by dividing by 6, and then that's my total number of inches in the scale model, which would be much smaller, much more adorable, equally rectangular.